so you have something like this that builds things up towards this conductor, and the result when that something like that diagram applies to a human being is something like this, right? You look at a part of the star cloud, and the human apparatus as an interface renders this. So the conductor experiences this as the rendering of reality with capital R. Or if it's an AGI or just a very, very well-performing AI aligned with humans, they will also, we believe or we desire, they would also perceive something quite similar, so that, you know, we're able to communicate with them depending on what they want. But I think the assumption with AGI is very much that they would reach something quite like this. Because if they don't, we might not even recognize that they're AGIs. So they need to be aligned, right? That's the whole discussion with alignment. Now, I find this view a little bit too clear cut. So then I get much more excited and entertained by diagrams like this. So it's a bit hard to read the labeling below each of these bubbles, but it presents an evolutionary tree that starts from, you see here on the bottom corner, from evolved life forms, design mechanisms, and artificial intelligences. So these three sources of creatures kind of start to mix and intertwine to result in a beautiful variety of agents. So if you think about it this way, you have a chance to loosen up a little bit on the heaviness of that diagram that builds up in layers to the conductor and so on, which is very much, again, married to how we think the human physiology and what we think consciousness is and so on. And this diagram comes from Michael Levin, who's a biologist. And this is how he describes that diagram. In your lifetime, you're going to be confronted with all sorts of novel beings. So all of Darwin's endless forms most beautiful are a tiny corner of this whole space. So hybrids and cyborgs and all kinds of non-neurotypical humans with implants and different kinds of connections to other creatures and technical systems. Pretty much any combination of evolved, engineered, and software material is some kind of being. So it's not about the language models of today. It's about beings that are nowhere with you on the tree of life. So this is the kind of technological future that makes me feel like I'm finally living in my favorite sci-fi novels. And if you are connected to, you know, even parts of the VR community that uses full body tracking and so on, you are already experiencing part of what he is describing here. So like I said before, this approach breaks us out of what I think are a very rigid ways of thinking about AIs and the issue of alignment and AGI, and throws us into a new way to think about evolution. I love the fact that in this diagram, again, the evolved life forms, the design mechanisms, and the artificial intelligences are on the same line. As you've probably picked up from my previous talks, I think when people keep using the word humanism and defending humanist values, they don't fully know what they are talking about. And for us to really properly guide things in the right direction through this interesting technologically heavily times, we actually need to ditch the old notion of humanism and redefine things quite a bit, because humanism as it is used and understood today is still the humanism that came out in the 1700s and defined at the time, and it's absolutely obsolete as a concept. So it doesn't mean that I think humans are inferior or we need to transcend being human or any of that. Not at all. I'm just saying we need to get rid of all concepts that have been formulated hundreds of years ago. So in this brave new world, one of the key things will be how we're going to relate with all of these type of creatures and what is the kind of ecosystem that these things are going to be to operate inside of. Now, related to this, there is a paper that is very beautiful called Evolution of Brains and Computers, The Roads Not Taken. And I'm going to read this part here. So some traits of human thinking will be common as bilateral symmetry, segmentation, tubular guts are in biology. It's interesting they mentioned bilateral symmetry here because yesterday we talked about the verticality of human beings. So verticality, bilateral symmetry, all of these are attributes of certain types of mammal life forms. But a possibility space of viable minds will likely contain traits far outside what we have evolved. It is not necessary that this type of thinking be faster than humans, greater or deeper. In some cases, it will be simpler. Our most important machines are not machines that do what humans do better, but machines that can do things we can't do at all. Our most important thinking machines will not be machines that can think what we think faster, better, but those that think what we can't think. And I think this is exactly the proposition in Levine's diagram. And it's exactly what I think is being missed in a lot of conversations. So here, the paper contains these type of diagrams that use 3 different axes to map biological agents and artificial agents. So this one maps them according to agent-to-agent interactions, autonomy, and computational complexity. So if you go in here, I think the paper is a little bit old, so you see that they have mapped in here things like AlphaGo and Watson. But then you also have insects, hydra, bacteria, bees, ants, humans mapped in here, humans still being all the way up there. Basically, humans in this diagram are the maximum point of their ability to do agent-to-agent interaction, autonomy, and computational complexity. But I would love an exercise where we go back to Levine's diagram and read some of the types of creatures and hybrids he has there, and try to maybe give them a bit more of a definition in terms of how they function and try to map them in here. This diagram maps them in terms of number of agents agent complexity and extended mind. We would have to go and come more carefully through the paper to actually understand what how the authors of the paper define these things. I don't want to make any assumptions, but you can see a little bit where they're going with the intent, and the intent being just highlighting the extra degrees of freedom in terms of all of these things that we now can talk about, because we have added into the mix of evolutionary agents things that are pieces of software, that have pieces of mechanical devices, and so on. And the last topic in the conversation about agents that I want to bring up is this concept of hyperobjects. This is also the title of a book by Timothy Morton, who is a philosopher. And the book is, in essence, a book about ecology. But I think it applies to this discussion at all levels as well. In his definition, hyperobjects are things that have magnitude on certain axes in terms of certain parameters, sometimes in terms of a lot of parameters. They reach scales and magnitudes that are beyond the human understanding to such an extent that we just cannot grasp them. They're just absolutely unfathomable. And he talks about us only being able to experience shadows of them, but the shadows themselves are, again, projections of these things which are unfathomable. And even if we go and analyze what we believe the characteristics of those shadows are, we still have almost absolutely no chance of really grasping and wrapping our minds around the actual hyperobject. So in this category, he includes things like capitalism, which just reach so deep and so wide in both time and space into all areas of human activity. Nuclear waste, the repercussions of things like atomic bombs, nuclear disasters, things like climate change are also a hyperobject. This concept has attracted a lot of strong thinkers. There are a lot of books, there were art exhibitions, all sorts of cultural productions that came out in the years after the publication of the book, all fascinating. So of course you can think of mushrooms and the mycelia that mushrooms grow out of, actually, like the network that's covering the entire planet as a hyperobject. And we know that they also, this mycelia subtends all of life forms in ways that we're still researching, we're still trying to understand. But this is the aha moment for me in this context, when I realized that a truck is a hyperobject for a frog. So let me explain why this thought, when it occurred to me, was so important. At the start of cybernetics in the 50s, people were studying vision. and I mentioned this 2 days ago as well. So Varela, Hoffman, a lot of people interested in this topic started by looking into vision and how vision works and how the information that hits the retina goes to the brain and other parts of the nervous system, and how that gets transformed into what we perceive as an image, as the world. And I think it's not coincidental that a lot of people who did their PhDs and their core research in vision ended up later on in their career doing work in AI. So in the 50s, again, at the start of the cybernetics, so we're talking about the time when the Macy's conferences were happening. There was this paper that was really well known about vision and frogs. And the paper was looking, or the hypothesis the paper was concerned with, and the study was, are frogs just not able to see trucks because of like neurophysiological reasons, or for other kind of reasons? So they did a bunch of stuff to try to get an answer to that. And I haven't read the paper in a long time, so I might get some of these details wrong, but the gist of it is that in terms of neurophysiology, frogs are to some extent able to understand trucks, but because they are so focused on food, everything their brain is wired for is finding and catching food. Although the information about large moving objects existing in reality with capital R, or in their interface, does enter the retina and the brain, it does not get processed by the brain. It gets discarded. The only information coming through their retina that gets processed by the brain in creating the frog's understanding of reality are tiny moving objects like flies, because that's what they eat. So ontologically, from the frog's perspective on reality, large moving objects do not exist. That's why frogs get run over by trucks all the time. When I grew up, the roads were like filled with these flattened out frogs. They just don't move if cars and trucks appear on the street, although technically their eyes can't see them. So that, thinking about that paper led me to make the statement that a truck is a hyperobject for a frog, and that we not probably, but definitely have this relationship as humans with a lot of stuff, a whole shit of stuff. We must have this relationship with so much, because just like frogs, we are also optimized to only see, like I talked about yesterday or 2 days ago, to only see things that serve our human purposes and that we can interact with in ways that further human needs and desires. It just happens that trucks are part of our world, but many other things are not. And we do know from recent studies that the brain uses less than 10% of the visual information that hits the retina. And that can be explained to a large extent by the, what is it called? We talked about it yesterday. predictive coding theory, but there are also things out there that are in this category. And then I do think there is another category as well, all the stuff I mentioned earlier, like capitalism and the mycelia of mushrooms, that it's not like we understand it, the whole thing is there and it hits our retina and we just don't process it, right? That's in a category where probably no part of our biological apparatus as humans comes in contact with the full object, the full hyper object in any sense of the words. So that's really like worst case scenario. And we do have like long list of those things as well. Okay, so I'm bringing this up because the fact that we have now the emergence of all of these additional types of intelligent agents that we share parts of our reality with puts the existence of hyperobjects from a human perspective, I think, in a different light. In a certain sense, definitely perhaps an optimistic light, but I think the situation is probably more complicated than that. So in the cloud of stardust that is reality with capital R, we have the human agents that with their biological interfaces render the particles to look like this, people and chairs and clouds and trees. And then we have all of these other types of creatures and forms of life and non-life that render that in their own ways. And then we also have these things called hyperobjects that we can't even properly define.